Hello, my name is Jacob Parks. And tonight we will be traveling to multiple exoplanets. I will start our journey roughly 23.6 light years from Earth in the constellation Scorpius. Here lies the trinary star system Gliese 667. All three stars in the system have masses smaller than our Sun. The two brightest stars, GJ667a and B, are orbiting each other in an eccentric orbit that brings them as close as 5 astronomical units or as distant as 20 AU from each other. The third and smallest star, GJ667c, orbits the AB pair. This star and its system is our destination. As you can see, the Gliese 667c system is much different from that of our own solar system. More massive planets packed into closer orbits around their red dwarf star. The largest planet in this system actually orbits closest to its star. While much of the Gliese 667c system remains a mystery, we have confirmed at least one planet in the habitable zone and think there could be two more. This first and confirmed planet we will call Chagorus. Chagorus is what we call a super-Earth. At nearly 4 times the mass of Earth, this world zips around its star in just 28 days. The high gravity of Chagorus holds a thick atmosphere around the planet. This helps to balance the temperature extremes on the planet despite it being tidally locked and leading to a wider habitable band along the terminator line. Though this thick atmosphere is a double-edged sword. As one side of the planet bakes in the sunlight and the other freezes, it creates massive high and low pressure zones that lead to superstorms. Chagorus orbits very close to its star. This proximity to the star and other massive worlds in the system causes the planet to undergo a lot of tidal heating. Volcanic eruptions are common as the core of the planet is needed. Despite these harsh conditions, the clouds part and we can see a world with lush vegetation, wide plains, and shallow seas. While this planet is quite diverse, we will focus mostly on the middle zone. Here, temperatures are most moderate, and we expect to find the greatest diversity of life. As we descend, we would find it to be rather dark, twilight of an already dim red star. The first surprise on Chagorus comes quickly. Gravity has so densely packed the air molecules together as to make it closer to water. Because of this, even though there's high gravity, the seeds can float on the wind currents, similar to dandelion seeds here on Earth. On Chagorus, it seems most of the planets have adopted this method, and the air is thick with seed clouds. It seems here this is also a method of pollination. As the seeds of one tree get caught in another, they pass on their pollen. Landing any sort of craft on Chagorus would be difficult. With over 90% of its surface covered in shallow seas or muddy plains, solid ground is hard to come by. We humans may have a hard time here, but microbial life thrives in this warm volcanic soup. Unlike here on Earth, where life developed using photosynthesis to turn sunlight into energy, on Chagorus, most of the energy comes from the planet itself. There are countless microbes that are using chemosynthesis to turn chemicals released by volcanic activity into energy. Great colonies of these microbes, living and dying, have created chimneys around volcanic vents. These structures range from about 1 to 3 feet and dot the landscape. Billowing clouds of volcanic gas pour from the tops. Occasionally, one will burp, throwing a flurry of white snow-like powder floating off into the air. This is a sign of even more microbial activity beneath the surface. These bacteria and archaea make up the base of the vent community food web and support thousands of different animals. We see an analog to this on Earth. In the oceans, we can find hydrothermal vents, whole communities of tube worms, mussels, shrimp, crabs, and more that live and thrive in these harsh conditions, extreme temperatures, salinity, and other chemical extremes. Many of the animals on Chagorus use another tactic to help ensure survival: symbiotic relationships. On Earth, we have seen ants farm aphids. The ant will use its antenna to massage the thorax of the aphid. This will result in the aphid releasing a sugary substance that the ants love. On Chagorus, we find a purple six-legged insect that resembles the ant in many ways. The shell sculptor, as we will call it. They live in giant super colonies across the planet and have come up with a rather ingenious way of maintaining their structures in the mud. They will carry scraps of food near the mussels for them to eat. By keeping them overfed, the mussels will produce excess shell material that the sculptors will then use to line their tunnels. As it hardens, it creates a rigid but slightly flexible structure that holds up in the shifting mud. Some even poke out of the ground, evidence of constantly shifting geological terrain. We have barely scratched the surface of the life that abounds on Chagoris, but we still can't help and wonder, in such a harsh environment, how is it that such a diversity of life is maintained? The answer led us to the discovery of intelligent life, just not as we would think of it. Across the planet, into the hottest deserts and the darkest ice sheets, there's one constant, a fungus. And the more we look, the more of this fungus we find. The actual mushrooms are just the tip of the iceberg. They seem to have a network just under the ground that links the entire planet. The spores are everywhere, in the air, in the water, and they are inadvertently eaten by every animal on the planet. The spores will live inside the plant or animal in a semi-dormant state. Here it will record what elements its host thrives on. Does the creature like sulfur? Does this other one like nitrogen? Etc. However, when the creature dies, the spore will finally begin to grow. As it does, its roots will eventually connect with the rest of the mycelium network. It will then ask that more microbes and elements that would help its host creature survive be sent to that location. On a larger scale, this mycelium network will maintain entire ecosystems. Only time will tell if this fungus will be able to maintain its complex biosphere, or will Chogoris soon suffer the same fate as Venus. I hope you enjoyed our journey to Gliese 667cc. Thanks for watching.